Hello everyone. In this video hello everyone. In this video we can verify few complex valued function whether it is analytic or not. So first one, consider that verify that f of z is equals to e power z is analytic or not, and find its derivative, that is f dash of z. So for this, given function is f of z equals to e plus z, and in the polar form, in the Cartesian form, we know that z is equals to x plus iy. So in that case, we can write it as f of z is equals to e per x plus iy. So by using the laws of indices, e per or a per m plus n is equals to a per m into a per n, we can write the e per x plus iy as e per x into e per iy. So further, by using Euler identity, we can write e per iy as cos y plus I sin y. So which is equals to e power x into cos y plus I times e power x into sin y. So this is the function f of z. It is there in the form of u plus iv. So on comparing, we may write the real part as e power x into cos y, and v value is e power x into sin y. So once we got the real part and imaginary part, we know how to find whether the given function is either analytic or not. So for that, the given function f of z is equals to u plus iv is said to be analytic if it satisfies the CR equations. So what are the CR equations? So that is ux is equals to vy and uy is equals to minus vx. If the given equation satisfies these two, then we can conclude that the given equation is analytic, that is the given function is analytic. The detailed derivation for this Cauchy-Riemann is equation is derived in the previous video, or you can find the link in the description box. So we got the u and v. So now we need to differentiate. So what is u? U is equals to e power x into cos y, and v value is e power x into sin y. So first differentiate with respect to x. So both we need to differentiate u and v with respect to x. So by using the chain rule or by using the product rule, we can apply the derivative, that is ux is equals to, when differentiating with respect to x, the function of y is treated as constant, means cos y will be treated as constant, we will get as it is. So e power x differentiation is e power x, cos y will get cos y itself. Similarly, it follows in the v case also, vx is equals to e power x into sin y. So now differentiate u and v with respect to y. So on differentiating, we get uy is equals to, differentiate e power x is constant, so differentiation of cos y, we know that its differentiation is minus sine y, and Vy is equals to e power x into differentiation of sine y is cos y. If you observe the equations, these two equations means equations A and B, ux and the value of Vy is same. The value of ux in A is same as the value of Vy in B, and the value of Vx is the negative of the value of Uy, or Uy is the negative of Vx. So therefore, Ux is equals to Vy, and Uy is equals to minus Vx. One is the negative of the other. So therefore, we can conclude the given function f of z is analytic. So once we computed it as analytic, we need to find the derivative f dash of z. So for that, so while differentiating the Cauchy-Riemann equations, we got f dash of z is ux plus I times vx. So vx is known, that is the ux and vx both are known. Ux is e power x into cos phi plus I times e power x into sin y. So now in these two terms, e power x is common, we can take it outside. E power x into cos y plus I sin y. So again apply the Euler formula in the reverse order. What is the Euler formula? E power I theta can be written as cos theta plus I sin theta. If you apply in the reverse order, we can write the cos theta plus I sin theta as e power I theta. So we can write it as e power x plus I y. Together we applied the loss of identity, that is a power m plus n is equals to, what is the loss of identity? A power m plus n is equals to a power m into a power n. By applying this, we'll get that. So e power x plus iy. So again, x plus iy is z, and substituting back, we got f dash of z is equals to e power z. So this is way how we can check whether the given function is either analytic or not. So means the function is differentiable, then only we can say that the given function is analytic. For every analytic function f dash of z exists. So take down the second one. Verify whether f of z is equals to sin z is analytic or not. To check whether the given function is either analytic or not, first we need to find the real part and imaginary part of this function, then differentiate the function with respect to x and y, real parts and imaginary parts, then check for the Cauchy-Riemann equations. We know that z is equals to x plus iy, so we will get f of z is equals to sine of x plus iy. So sine of a plus b formula is known. So what is the sine of a plus b? Sine of a plus b is equals to sine a cos b plus cos a sin b. So on using that, we can write the sine of x plus iy as, so sine of x plus iy can be written as sine a cos b, that is sine x cos iy plus cos x into sine iy. So here, to check, to find the, to separate the real and imaginary part, will I use two identities. One is cos iy is the same as cos hyperbolic y, and sin iy is same as I sin hy. So using these two results, we can write it as sin x into cos hyperbolic y plus I times cos x into sin hy. So on comparing, we can call this as the real part u, and the other one which is multiplied with I as the imaginary part. So here we will get u is equals to sin x into cos hyperbolic y, and v is equals to cos x into sin hyperbolic y. So once we got the real and imaginary part, differentiate u and v with respect to x and y separately, and differentiating, we will get ux as ux differentiation of sin x is cos x, cos hy is will get as constant, so we will return as it is, and vx differentiation of cos x is minus sin x into sin hy. Similarly, differentiate u with respect to y, uy is equals to sin x into differentiation of cos hy is sin hy, and vy is equals to cos x will be written as it is, sin hy differentiation is cos hy. So now on comparing the last two equations, means on comparing say it as some equation A and equation B. So if we note this, ux value is the same as vy, and vx value is the negative of ui. So therefore ux equals to vy and uy is equals to minus vx. So therefore f of z is equals to sin z is analytic function. So now, so we, since the given function is analytic, its a differentiation exists, and its differentiation is given by, so f dash of z is equals to ux plus ivx, and substituting the value of ux is cos x into cos hyperbolic y plus I times vx value is the sin x into sin hy. We can go back and we can check once. So vx value is negative sign, so the plus sign will become minus sign here. So now we can simplify by replacing cos hyperbolic and sin hyperbolic relations, or simply replace replace x by z and y by 0, we get, and replacing that, so we'll get cos z into cos hyperbolic 0 minus I sin z into sin hyperbolic 0. So by noting two values, cos hyperbolic 0 value is 1 and sin hyperbolic 0 as 0, so the value of this second term will goes to 0, so the value of this term will goes to 0, so we'll get only cos z. So this is the differentiation of the given function, that is f of z is equals to sin z. Thank you for watching.